7.3 Sketching slope fields. So a slope field just represents a differential equation on an xy plane. It shows the slope of all the particular solutions to the differential equation. So here we have a differential equation dy dx is equal to 2x and the accompanying slope field. So all this is here, right? So let's take this point right here, negative 1 comma 1. If you plug this into dy dx, oh, that's just 2 times x, which is negative 1, which is negative 2. You see this right here, this steep downhill, that's a slope of a negative 2. This is all it is here, right? If we picked another point here, let's just say 1 comma 1. You plug it into your differential equation, dy dx is equal to 2 times the x-coordinate, 1 equals 2. So you see at 1 comma 1, this point right here, we have a slope of 2. And if you notice, whenever x is 0, you see these are all horizontal hash marks. Let's do an example here. So use the differential equation to create a slope field. So dy dx is x times y. So there's a few different ways you can do this. So you can individually test every single point you have here. So if you did, let's see, 0 comma 2, which is this point right here. If it's 0 comma 2, if x is 0, y is 2, it's just 0 times 2, dy dx is equal to, well, 0. So that's a horizontal hash mark. Well, if you notice here, right, whenever x is equal to 0, well, 0 times whatever y is, you have a horizontal tangent line. So all along x is equal to 0, dy dx is always 0. Also, same thing when y is equal to 0. When y is equal to 0, no matter what x is, you're going to have these hash marks here. At 1 comma 1, you have a slope, it's 1 times 1, which is a 1. So that's just a straight diagonal like that. At 1 comma 2, you have a slope of 2, because 1 times 2 is 2. So that's a little steeper uphill. At 1 comma negative 1, 1 times negative 1, that's a negative 1. So slope here is negative 1. And then 1 comma negative 2, it's negative 2 right there. Try these out on your own. You can pause it if needed. All right, so you don't have to be perfect with these, but what you should have for question 1 is something that looks like this right here. Let's go on to question 2. Again, this is where you just plug in points here into the dy dx to do the slope. So at this point here, negative 1 comma 2, at negative 1 comma 2, I'll use y prime for now, because that's dy dx. Y prime is equal to 2 minus 2 times negative 1. So that's equals 2 minus 2 times negative 1, which is equal to 2 plus 2, which is 4. So the slope here would be 4. You can pause the video and try all these out on your own. You should have something like this. Should be pretty straightforward. If you have questions, please ask your teacher, ask a classmate for help. But you're just plugging in the coordinates of the point into the derivative, the differential equation here, to find what the slope should be. So this next question right here, the figure below shows the slope for the differential equation right here. Let f be a function that satisfies the given differential equation. Write an equation for the tangent line to the curve that goes through the point negative 1 comma negative 2. Tangent line here. If you remember the formula for a tangent line, it's y minus y1 equals m times x minus x1. Well, we have our y1, which is negative 2. Y minus negative 2 is y plus 2 equals m. We're going to leave that. Oh, what's our m right here, actually? So it's just whatever the derivative is when you plug in this point. We have dy dx, so our m is just equal to 1 minus parentheses x is negative 1 times negative 2. So m is equal to 1 minus 2, which is negative 1. So m is negative 1, x minus negative 1, which is just a x plus 1. This is your answer right here. You don't have to worry about doing anything with the graph for now. We're going to be doing more stuff with that in the next lesson. All right, this last question right here. Below is a slope field for which of the following differential equations? So in the previous page, right, we were given a differential equation, then created a slope field. This is just going backwards. You're given the slope field. Which equation is it? So, um, so one of these, A, B, C, D, or E, matches this. And there's some different ways you can do this. So for example, the easiest way to do these is look at where the horizontal hash marks or if any straight vertical hash marks are. So you can see there's horizontal hash marks along this entire line, right? When x and y are the same value, or sorry, when x and y are opposite values, so when y is equal to negative x, so if y is 1, right? X is negative 1. When x is 2, y is negative 2. We have these hash marks here. So, like for example, A, if we plugged in negative 3 for x and y is 3, we should get a slope, a dy dx of 0, because there's a horizontal hash mark. So if we have the point negative 3 comma 3, we should have a dy dx equal to 0. So for A, right, if I plugged in x is negative 3, that's 1 plus negative 3, that's negative 2. So we know, well, that's clearly not a slope of negative 2, so A is wrong. Even if you look at this one too, if x is negative 1, whenever x is negative 1, the slope, the hash mark should be horizontal, but clearly in the graph you see it's not. Let's just try this point again, negative 3 comma 3. Literally just pick any point where there's a horizontal hash mark, or if you know if like the slope's positive or negative. There's no one way to do this. So if I plugged in negative 3 for x, using this here, right? Negative 3 squared, that's equal to 9. That's clearly not a slope of 9, because it should be a slope of 0. Boom, boom. So in C, right? If we have a negative 3 plus 3, that is 0. So it could be the right answer, right? But we don't know. Right now, let's make sure we check the other ones first. It's just process of elimination. So if we did negative 3 for x over 3, that's a negative 1. Nope. We should have a dy dx is 0. Cross that out. Let's see. Plug in 3 for ln. That's ln of 3. Well, if you put ln3 in the calculator, that's not 0. It's not equal to 0, so you can cross that out. Oh, so in this case, we tried it out, and the answer here is C. This is, we were lucky with this, with the points we chose. Sometimes it requires testing more points out and using process of elimination to figure out your answer. Any questions, ask your teacher. Otherwise, go ahead and start the practice.